Hey, last time I tried to have you guys think about different ways to obtain circular motion. We looked at tension, force. What's an example of tension causing circular motion? Normal force. What's an example of normal force? Gravitational, friction. Oh gosh, what caused a curveball, right? I'll have a separate video on that. But what we were exploring was circular motion, and we were exploring what forces cause circular motion. Whenever there is circular motion, there is a force, okay? And that force, if we look at the most, hi Grace, the easiest, right, example of seeing circular motion, what force causes that circular motion is a ball on a string. Because we know the string is the part that's causing that force, which means there's an imbalance of force that causes the ball to be in circular motion. If I let go of that string, right, the ball wants to go in a straight line motion. Now, I let it go and there's still force of gravity, so it's going to curve. But what we've got, circular motion requires a center-directed force, okay? That center-directed force, and I just say force with a subscript of C, center-directed force is called a centripetal. That's a physics word for it, centripetal. Centripetal force is just a center-directed force, and we use force sub C, okay? Now, what I want you to do in this assignment is, what could we change, okay? This kind of goes back to some of our labs. What do we observe, okay? What things could we change about this setup to change the centripetal force, okay? So some of you are probably like, I bet you if you were to do this, you could feel the different force needed to keep the ball in a center directed when I pick up the speed, okay? You could also think about driving around a turn, okay? If you did that at a faster rate with the force that's keeping you in center, the force on your tires, or on your passenger, the force of the door, right? Keeping you in that curved motion, right? What if you change the radius, right? What if you change the radius? If I enlarge it or decrease it, what's that going to have, or what is that going to happen, or how's it going to impact the centripetal force? And then the last thing, I bet you're already figuring this out. What if I had changed the mass of this ball? What if this were lead or steel instead of foam? Okay? What happens when we change the mass? So these are all things that impact the centripetal force. And I'm going to ask you, what happens to that force if I increase or decrease either one of these things, and see if you've got a good intuition about it. All right? That's it for today. Have a good one.